current shunt feedback, since the input is also having shunt, their input resistance will decrease. Output is also having parallel components, output impedance will also decrease. So in the current shunt feedback, both of them will decrease. We'll see both of them will decrease. Is it correct? So input side I have shunt, and output side I have current will be same in series. So output side the resistance will increase, input side the resistance will decrease. Is it clear? See, I once again say current shunt feedback. Output side la current will be same in series. In series resistance will increase. So current shunt feedback la output side la resistance will increase. And since we have shunt at the input side, you know when you connect many components in shunt, the resistance value will decrease. So input side la the resistance value will decrease. So RIF will decrease, R0F will increase. So logically, name length, first we have to understand what will be the impact of RIF and R0F. Other than mathematical circuit, we are going to verify whether we are getting the same when we apply KVL and KCL in our circuit. And see here, both the input and output sides are having Norton's theorem. Norton circuit, now any current source parallel to a resistance is called as Norton circuit. Current source parallel to a resistance is Norton circuit. Voltage source series with resistance is called as Thevenin circuit. So here, because we have current shunt feedback, both the sides we have Norton circuit. I told you why current source is coming on both sides. So whenever current source comes, we denote it by a name called as Norton's model. Okay, current source parallel to resistance is Norton's equivalent circuit. Voltage source series with resistance is called as Thevenin's equivalent circuit. So here at the input side, I will apply KCL because three currents are there. I will apply KCL in this node. So one current is coming, two current is getting splitted. So IS equal to IF plus II. See here, simple KCL equation. IS equal to II plus IF. And you know IF is beta into I naught from the expression for beta. Beta is equal to IF by I naught cross multiply. IF equal to beta into and substitute that. So IS equal to II plus beta into I naught. So this is one equation. See, for finding input resistance, you know, you have to get the form V by I. But இங்க எல்லாமே I தான் இருக்கு, correct? So I need to bring in voltage. For that, what I should do? You have only one parameter. So find the expression for I naught. So I naught, same way current division technique, output side, you see total current is AI into II. It is getting split into 2. So same way, I naught is the current flowing through RL. So I naught equal to total current AI into II into opposite resistance. So for finding the opposite resistance, what rule I told you? Hide the resistance across which we are finding out the current. So I want to find I naught flowing through RL. So assume that RL is not there. Whatever is remaining is your opposite resistance. So AI into I naught into opposite resistance R naught divided by R naught plus RL. Opposite plus that resistance. So I am denoting AI into R naught by R naught plus RL as A capital I. See, remember, these are all small notations where we use to simplify the expressions. So இது போடாததுனால answer தப்பானா no, answer is same. Just to make your expression look simple, we are clubbing this big term AI into R naught by R naught plus RL as A capital I. Okay, now what I should do, substitute this value of I naught in the first equation, whatever we have